It's SMTConnect 2023 in Nuremberg. It's day 2. I'm joined by David from MindCet. Thanks for coming over.
Thanks for the invitation. It's great to be here.
Good to meet you. We haven't spoken before, so tell me all about MindCet.
So, MindCet. We're an IC design house, fabulous, based in Belgium, specifically in Leuven, for those that know the area a bit more. Yeah. Our focus is on power and high voltage, and that's in the terms of analog and mixed signal design.
Yep.
So that means oftentimes designs are everything that our customers come to with their specifications for power management, like DC-DC converters for point of load, or it can be things like gate drivers, MEMS drivers. Drivers is a keyword here, as we're starting to hear. And we handle those developments for our customers turnkey, meaning from the very beginning of the design, moving on to final packaged devices that we can production test in-house for our customers.
So your customers, they come, we want to achieve this, and we want to do it in the lowest possible form factor or whatever.
Exactly. It could be a number of reasons. It could be, as we saw especially with Corona, there's been a lot of shortages on the market. Sometimes it can mean we can't get our hands on this part, and it's a key aspect that we need. We have high volumes that we use, so we're reliant on this. That's one reason. Another reason is the part doesn't exist on the market. They're trying to do something new or exactly integrate it smaller, more functionality together. Volumes typically behind it. The last reason can also be IP protection. You don't want everyone to be able to see what you're doing when you look at a board. It's much easier to figure it out, put it on chip, integrate it together. You have a key product that everyone else in the market can't easily copy.
Yeah. So you're working with customers very closely then, isn't it?
Yeah, exactly. All our customers are always, in almost every single situation, it ends up becoming a long-term relationship. The business we're in, it's not here, buy some chips from us, and then we're gone and never hear from them again. It's the process, even to begin a project, can take easily 6 months, and then the IC development itself can take anywhere between 3 to 6 months on the faster side, but it still has to go to the foundry. It has to be produced, come back to us for characterization. But even that working model, we work with our customers closely because how some of the logistics work, that's going to be customer dependent on their own preferences. We like to match those.
And I guess demands are changing all the time, especially with electric vehicles and the whole, digitalization of workspaces. You're getting quite different demands now, I guess, aren't you?
Yeah, there's definitely some industries for sure that are growing and asking more. As we talked about, especially power management, that's becoming, as we have more and more high power computing. You need to supply those chips with that amount of power. How do you do it? We're talking smaller and smaller form factors. You have to think about thermals, you have to think about losses, all which is part of the overall, not just chip design, so really from the bottom up, chip design into the system level. And at least we play a key part in, for example, the power management and helping our customers with that.
So a show like this is great for seeing existing customers and potential new customers. What are you talking about at this show? What products have you got here this year?
So, in addition to the ASIC design services, we can call it a little bit more of a semi-abstract concept. I luckily can also have a few things I can show because we have expanded our business based on that expertise we've built up in IC design, in power. We've introduced a 200-volt gallium nitride gate driver, highly integrated, and that's something that we're showing very tangibly. This device is, as I mentioned, a 200-volt, non-isolated gallium nitride gate driver, and it's with high reliability in mind, high integration on chip. And to get customers' hand on this, it's we put together a nice kit.
Get a kit,
As the box itself, company's called, it's a reusable box. I have to say, I have a few of these at home that I'm using as well. We have them all over in the lab.
Yeah.
If we're going to do something, you want it to continue to have use, right? But then when we open it up, what the engineers really care about is this board here.
Yeah.
Still in the ESD package. I have another example that I can show in a second. But this is really it's a buck converter, so simple topology, but that half bridge is a key in so many applications.
Yep.
So we want to let customers get an idea for GAN and get an idea for a gate driver and how the marriage of the two works.
Yeah.
And then on top of that, we want to make sure that it's easy to then ultimately design in. GAN has wonderful properties, but you have to do it right.
Right.
And gate driving is one part of it. And we want to make that easy to do.
Yeah, fantastic. And that's that shows it in one easy set.
Exactly. The cables, the fan, everything.
Yeah.
So of course you need some of your own lab equipment, but other than that, you're good to go.
But it's a good way of getting people's head around it, isn't it?
Yeah, I think there's nothing more for an engineer than being able to sit down and look at the waveforms, push power through it, see how it's reacting.
Yeah. So people have been walking away from these from the stand, have they?
I wish, but you can gladly contact me personally. I'll hook you up with one of these kits.
Yeah.
And I should also mention, because we focus on the gate driver, we're flexible in which GAN transistor, GAN hemp suppliers we work with. We offer at this moment, we have two in stock, one with GAN systems and one 100-volt devices. And then we have one with InnoScience 150-volt devices.
Right.
On top of that, Nexperia is a newer collaboration that we've begun. They're 150-volt devices, and as it's a 200-volt driver, you have to do 200-volt GAN, and that's an EPC board that's finishing up the last characterization that we can.
And I guess more of those devices will
work.
Come to market as well, won't they, over time?
Yes, they're definitely already there, but the adoption, we're definitely on the upturn of the curve for gallium nitride.
Yeah.
And the application range is very wide.
Yeah.
And as especially the costs on GAN come down, as customers, even automobile, for example, they're really looking for the reliability.
Yep.
But they're seeing that, and now even automobile customers are adopting GAN for onboard chargers, for example, and other DC-DC conversion elsewhere within the car from bus voltage down. So it's exciting. So you've got that. You've got photovoltaic where it makes sense. You have, for example, for us, a personal favorite of mine is audio class D.
Yes.
So here's a good place where we can see our drivers right here.
Yep.
And on the inside is the two, frankly, tiny GAN transistors. So this side is one half bridge. On the other side, it's just symmetry because it's a full bridge, self-oscillating topology. And this can push potentially hundreds of watts to a speaker, and doesn't even need a heat sink.
Yes.
GAN's efficient.
Yeah. Yeah, that's a huge change, isn't it?
Yeah.
And small and light. That's fantastic. And it's a fantastic time to be in this, isn't it? Because the application is being found all the time. Like you say, people are adopting it.
Yeah, exactly. Like I said, the application areas are expanding. It's one of those things that, for example, the biggest so far adoption has been for all those wonderful quick chargers that we use for our phones, especially now our laptops.
Yep.
I appreciate nowadays carrying around this rather small 65-watt charger. That's GAN-based.
Yeah.
That's why, because it can switch at higher frequencies, thereby reducing the passive component sizes, the inductors, the caps.
Yep.
And that all in the end with good thermal design and the high efficiency that GAN offers creates a small package. And that's just one example of a market that's quick to adopt.
Yeah.
And as that happens, it starts to trickle towards industrial and even automobile, like we discussed.
Yeah. That's fantastic. Future is GAN.
The future is GAN.
Yeah.
I will admit, I think there's also going to be space for silicon MOSFETs, and also as well for silicon carbide. They still have their areas of work. There's definitely overlap.
Yeah.
There's plenty of other great experts that people can listen to, but in my mind and talking to customers, each has its niche. Yeah. And GAN, I think, ultimately will really take a lot of the silicon market, to be honest.
Yes, and it's fantastic, finding those applications and having the choice to choose the most suitable solution for it, isn't it?
Yeah, and that's in the end. the market will settle and figure things out. But we got to create the tools. We got to put it out there that designers can get in hand and work with it.
Which you're doing exactly with that. So
that's our goal.
Yeah. Well, fantastic. Thank you for sparing time to talk to us. I hope the rest of the show is successful for you. I'm sure it will be.
It's been my pleasure.
Yeah.
Thank you very much for having me.
Talk again soon.
Same to you.
Thank you.